Okay guys, so we're looking at worksheet 4.8, and this worksheet is about putting all of this together. Everything that we've learned about polynomial functions we're going to be doing on here. Alright, so first of all, we're only going to use our graphing calculator for computations when we're doing synthetic division. So if we're doing synthetic division and the numbers get really large, we may want to go ahead and grab our calculator. Otherwise, we will not. If we're trying to find extrema, do you guys know what I mean by extrema?
Local and
Yep, you got it. Extrema are those local mins and local max. And also we can check our graph with our calculator. Anytime we're finding extrema, we're going to round to 2 decimal places. All right, guys, so look at our function, our first one. Our first quadratic, y equals 6x to the 4th minus 11x cubed minus 22x squared plus x plus 6. State the maximum number of roots. Okay, how many roots are we going to have? 4. Okay, now, we are going to have 4. I know it says maximum number, but we must have 4 zeros. We must have 4 zeros. Some of them will be real. Some of them will be imaginary. All right, now we're going to write down the list of all possible rational roots. Do you guys remember how we do this? All right, let's start it. Plus or minus. Who's ready to tell me what these would be? Justin, you got it? What are they?
like on the top.
Can you think ahead as to what they... Just tell me the integers first of all.
3, 2, 1, 6.
Okay. Okay, so that would be the integers that we could have as rationals. You ready to keep going? Try it.
1 over 3. 2 over 3. 2 over 1 over 2. 3 over 2. 1 over 6. 1 over 3.
I think that's it too. Anybody think of any others? All right, I believe that's the only possibilities for our rational roots. Remember, rational means fractional. Anything that can be written in a fraction, even the number 1 is 1 over 1, 2 over 1, 3 over 1. All of these are called rational roots. Okay, in chart form, list the possible number of positive, negative, and imaginary zeros. All right, so when we say positive and negative, we're talking positive and negative reals. All right, so we look back at how many sign changes we have. How many sign changes do we have? 2, right? So we can have 2. We plug in a negative. A negative to the 4th is positive, that's positive. A negative cubed is negative times negative is positive. Negative squared is positive times negative. That would be negative, that would be positive. So what about the negatives? How many can we have? 2. How many imaginaries then? 0. Okay, now we know this can stay 2, but this could go down by 2. And so that would force that to be 2. This could go down by another 2 on the positives, and this could stay 2, this would be 2. Or we could have this situation. Those are all the possibilities that we may have. Okay, so now we have to state the upper and lower bound. We have to show synthetic division chart for proof. When we have the lower bound, all of the signs are going to alternate. When we have an upper bound, we're going to have all the same signs. All right, so here's what we do. We're going to come down to this space. I'm going to need a big chart. So at the top, I put my coefficients. I have 6, negative 11, negative 22, 1, and 6. All right. So I'm going to start with 0, and I'm just going to put it in the middle here. When I'm doing synthetic division, the first thing I do is I bring this down. So I have 6. Now I'm going to multiply these two. So 0 times 6 is 0, and I have to add. I have to multiply. 0 times negative 11 is 0, and I have to add it to that. 0 times negative 22 is 0. Add it to that. 0 times 1 is 0. Add it to that. All right, so we can see that this would be the y value. In fact, I like to do this. I kind of put like a squiggly line here, so I remember that these are just my y values. So if I plug in 0 for x, this is what I get for y. Okay, so now we're going to go up here. I'm going to do negative 1. I'm going to check that. Feel free to go faster if you've got the hang of this from the warm-ups. If not, watch. I bring this down. I multiply, and I add. I multiply 17, and I have to add. I multiply, and I get 5, and I have to add. I get 6. I multiply, I get negative 6, and I add, and I get 0. Okay, so what's that telling me right now then, guys? Yeah, negative 1 is going to be one of my zeros. Now, looking back at my chart, it says I have to have either 2 or 0 negative real zeros. So I already have 1, so I'm probably going to want to keep going down, right, and check for some more negatives. So I'm going to do negative 2. I'm going to bring down the 6. That's negative 12, add. That's positive 46, add. That's negative 48, add. Ooh, I feel like that's not right somewhere. Okay, I guess it's all right. Okay, this would be 94, and then I add. Yeah, Justin.
That would be the lower bound.
Okay, good job. He's right. This is the lower bound because, look, guys, it goes negative, positive, negative, positive, negative, positive. So, therefore, this is the lower bound. There's no sense checking for any other negatives down here because this is the lowest bound that we can have. This is the lowest one that could have a 0. So now I'm going to, yeah, Karen.
How do you know that it's the lower bound?
Because whenever these signs alternate, negative, positive, negative, positive, negative, positive.
And it's always like that?
Yep.
Okay.
See how this one went? This one is negative, positive, negative, negative. So that did not work. See? All right, so now I'm going to go up this way. 1, I bring this down, 6. I multiply and I add. I multiply and I add. Multiply is negative 27 and add. Multiply is negative 26 and I add. Okay, so I check. It's not an upper bound. I already know the lower bound. But what's going to happen in between 0 and 1? There must be a 0 there. So I'm just going to keep that in mind that there is a 0 in there. All right, so now I'm going to go up to 2, bring it down. That's 12, add. That's 2, add. Negative 40, add. And negative 78, and add. Okay, I still have not reached the upper bound. I'm looking for all of these across here to be positives. So I still don't have an upper bound yet. 3, bring it down. That's 18, and I add. That's 21, and I add. That's negative 3, and I add. That's negative 6, and I add. Uh-oh. So that's going to be what? Another 0 right there. So right now we are up to 2 zeros. Okay. Now one of these zeros looks to be in between 0 and 1, so it could be like a half or a third or a sixth. I don't know that for sure yet. I just want to go ahead and get this upper bound to make sure that there's no zeros beyond. I don't think there will be, though, because of that, but let's just show the upper bound. 24, and I add. 26, 52 and add, 120 and add, 484 and add. All right, so is this going to be my upper bound then? Yes, because all the signs are the same, positive, 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 all the way across. Okay, so therefore, my lower bound is at x equals -2, and my upper bound is at x equals 4. Yes?
So for the lower bound, it's when it's alternating. But for the upper bound, is it when it's all positive or when it's all negative?
It could be all negative too.
Okay.
And that's going to happen if I have a negative coefficient in front, where I'm going to be looking for all negatives. And actually, this doesn't really count. Like, it doesn't have to be that if this, well, this doesn't matter. It's this part of it that really has to be all the same signs, and these that have to be alternating. All right, find all zeros. Okay, so what are the zeros we have so far? What are they, guys? -1 and what else? 3. Okay, those are the only two real zeros that we know at this point. But we know there have to be others, right? Because we're not allowed to have just one positive real or one negative real. So there have to be others that we're just not seeing. Anybody have an idea of what I could do now to find the others? No calculator, though. Cat? Good. I'm going to do more synthetic division. What I'm going to do is I'm going to take this one right here. If I could factor it, it would be great, but it can't be factored in an easy way. But what do I know should go into this? What's my other zero? What's the other zero we found, guys? 3. So I'm going to divide this by 3. So I'm going to do 3 into 6, -17, -5, and 6. Okay, because that's what this is. This is really 6x cubed minus 17x squared minus 5x plus 6 is what that is. So now I'm going to bring this down. I get 6. I multiply. I'm just doing this the old way now. It's -2. And there we go. Okay, so now I'm left with this. So what would this now be representing? This is my constant. This is my x. This would be 6x squared plus x minus 2 equals 0. If I want to see if this is factorable, here's what I do. I multiply these. That's going to give me 12, -12. Are there numbers that multiply to be -12 that will combine to give me 1? What are factors of -12? -3 and 4 or -4 and 3? Those would combine to give me 1. This can be factored. Set up your double parentheses. 3x, 2x, 2, 1, plus, minus. All right, so then what are our zeros going to be? X equals what? Solve it quickly. What is it?
1/2.
Right. Just set each one of those equal to 0 and solve. Okay, so now we have our other zeros. X equals -2/3, x equals 1/2. Does it make sense then with our chart? Yeah, we have 2 negatives and we have 2 positives, so that works. Okay, write the polynomial equation as a product of linear factors. All right, guys, here's what this looks like. What is this solution as a factor? X plus 1. What is this one as a factor? X minus 3. What was this one as a factor? 3x plus 2. Without looking down, could you see what this one is as a factor? Can you think about it? 2x minus 1. Good. So this is just another way in factored form to write that original function. All right. Find the x-intercepts and y-intercepts. Well, the x-intercepts we already know. They were -1, 0, 3, 0, -2/3, 0, and 1/2, 0. Our y-intercept is when we plug in 0 for x. What did we get down here when we plugged in 0 for x? 6. Okay, so now we're going to start graphing this. Look at where these zeros are. Like there's a 0 at -1 and at 2/3. I might want to stretch this out quite dramatically. I'm going to make this be -1 and this be +1. See what I'm doing? I'm stretching out that axis. So -2 is going to be 1, 2, 3. And that's because I want to be able to put that 2/3 in there. So I'm going to make it look like this. All right, so I'm going to put these zeros in. So I've got x is -1, I've got x is 3, I've got x is -2/3, and I've got x is 1/2. All right, so there's my zeros, and then I've got an intercept at 6. But I'm going to look at these numbers and see how large they get. Like, I might want to put this point on my graph at 100. I don't know. What I'm going to do now before I finish my y-axis is I'm going to go to the calculator. This is the only thing you should need your calculator for is the extrema. You can't find those any other way. So we're going to go put this in. All right, I'm going to change it so that my window is set up like this. So mine is basically going from -4 to 4 on the x's. On the y's, I don't know. I'm going to keep it at -10 to 10. This may not be a good choice. We'll see. Hit graph. I have to be able to see those local max and min. All right, it's fine. Oh, no, maybe not so much. I need to see this bottom part. So I'm going to go to my window. I have to make my y-mins go down more. So maybe I'll try -80. I don't know if that's going to be good enough. We'll see. Ah, yes. Okay, so I'm going to look at my window now, and I'm basically really going from -80 to 80. So I'm going to make this go like by tens. There's -20, -40, -60, -80. There's +20, 40, 60, 80. All right. So now I'm going to start graphing it back based on my chart and also on these maxes and mins. I might as well go ahead and find these maxes and mins first. And I'm going to make this just go to 80 so it looks just like my graph. All right, so we have a minimum here. That's also called a turning point. How many turning points do we have then? 3. So I'm going to do second, trace, calculate. I'm going to find a maximum. I have to go to the left of it and to the right of it. And so my first max is at 0.0224. Oh, sorry, it says 2 decimal places. And it's 6.01. And I'm just going to put max above it so I know it's a local max. Okay, let's find the mins. Go to the left, hit enter, go to the right, hit enter. So that minimum is at -0.85, -0.86. And that would be a min. And then we have one more minimum. Okay, and this minimum is at 2.20, comma, -74.9. 85 actually, to 2 places. All right, so we've got those. So now I'm going to go ahead and plot those. 0.022 is going to be about really close to that, and 6.01, right about there. I've got that other y-intercept right next to it as well. Negative 0.85 is going to be right about there, just barely below that axis. And then 2.2 and negative 74 is going to be right about there. All right, so now I'm thinking in behavior, if it's to the 4th power, I know it's going to go up at the ends. So I know then, and plus I know this point, negative 2, 100. I might as well go ahead and put that point in there. So here we go. Going to come down like this, just barely dip below, come back up, go through these 2 points, come back down. I know another point at 1 is negative 20. I might want to go ahead and put that in. 2 is negative 72, right about there. And then I know that 3's my other x-intercept. Okay? Finally, looking at the end here, we already did that. Answer the following about the end behavior. So as x goes to negative infinity, guys, where's the y value going? As x goes to negative infinity, where's y going? To infinity or negative infinity? Infinity. As x goes to infinity, so as x goes down this way and gets larger and larger, where's y going? Infinity. So that's the type of thing you're going to have to do. You can see those take a while, so therefore on your test next block day, you'll only have 2 of those. One in factored form, one in this kind of form where you have to come up with the factors and everything. All right.